Okay, we're going to go through each one of these actually. I know this is stuff that we've done a long time ago. This is going to be merging our normal friendly chart that we're all kind of used to, that we'll have down with our quadrantal angles in our normal chart, and also with something called the cloud that we learned a long time ago is when you see the arc function. When you see arc sine of 1/2, that's the angle whose sine is equal to 1/2, and you're just giving me an angle. So the angle whose sine is 1/2 is pi over 6. So pi over 6 is going to be the answer there. Now, we had domain restrictions on these simply because they needed to pass the horizontal line test in order to have an inverse. So I wouldn't even worry about that right now. I would just know the domain for arcsine and arctangent are the same. They're in quadrant 1 and quadrant 4, and arc cosine is the oddball. That's in quadrant 1 and quadrant 2. And this is a cloud that we used before. We said regardless whether it's arcsine, arctangent, or arc cosine, if you see a positive number right here, you're going to give me the reference angle. So your answer will always be pi over 6, pi over 4, or pi over 3, no matter what. 4 right there. And then when you have a negative, when you have an arcsine and arctangent and it's negative, it's as easy as sticking a negative in front of that reference angle. So your answer is always negative pi over 6, negative pi over 4, negative pi over 3. If you have arc cosine that's negative though, you have to give me a quadrant 2 angle. And so it's always going to be one number less on the top. So your answer will always be 5 pi over 6, 3 pi over 4, 2 pi over 3. So we already said arcsine is 1/2 because when you look at the chart, the angle whose sine is equal to 1/2, that angle is pi over 6. But if I give you arcsine of a negative 1/2, arcsine of a negative 1/2, remember when it's arcsine or arctangent, all you get to do is stick a negative in front of that reference angle right there. When I give you arctangent of a negative 1, that's the angle whose tangent is equal to 1. Now just pretend it's positive for a second to get the reference angle. The angle whose tangent is equal to 1 is pi over 4. And so if that's a positive 1, I use the positive pi over 4. But since it's a negative 1, I just stick a negative in front of it and get that negative pi over 4 right there. And when I do the arc cosine of 1/2, it's positive. So your answer is going to come from quadrant 1. Your answer is going to be a reference angle. The angle whose cosine is equal to 1/2, that angle is pi over 3. So if that's a positive number right there, you always are going to give me a number straight from the top of your chart there, pi over 6, pi over 4, pi over 3. But see, if you have arc cosine of a negative number, you can't just stick a negative in front of there because that's in quadrant 4. Cosine is actually negative in quadrant 4 from your all Snickers taste chocolatey, right? So when you do your arc cosine negative 1/2, that's if you're using the cloud. Arc cosine is negative, you have to give me a quadrant 2 angle. And so we just said pi over 3 is the reference angle. So you're going to give me a quadrant 2. You're going to go 2 pi over 3. And you can do the quadrantal angles with these things as well. If I say, what's the arc sine of 1? That's the angle whose sine is equal to 1. And that's on your unit circle where your y value is equal to 1. That's up there. All right. And so that's the only spot. So if I say, what is that angle? You're going to tell me pi over 2 for that. And so this problem is mixing all of these things together. So we're going to have to do a mixture of the chart and we're going to have to do a mixture of the cloud. You only use the cloud when you see the arc notation. That's like cosine inverse right there. So let's just do one thing at a time. Let's do these together. So the first thing I'm going to do when I says cosecant and sine, those are your normal chart things or your quadrantal angles. So sine of pi over 6, sine of 11 pi over 6. Remember, pi over 6 is your reference angle. And so sine of pi over 6 is going to be 1/2. But you're in quadrant 4. So if you use your all Snickers taste chocolate in quadrant 4, sine is going to be negative in quadrant 4. So I'm going to put a minus right there. And then the cosecant of a quadrantal angle. Remember, cosecant of theta is 1 over the sine of theta. So when I have a quadrantal angle, that's what I'm going to do there. And so 1 over sine of pi over 2, sine of pi over 2, that's right there at the point 0, 1. Remember, the sine is your y value, cosine is your x value. So sine of pi over 2 is right there at 1. So 1 over 1 is 1. So 1 minus 1/2 gives us 1/2 in the parentheses. But now you're supposed to do the arc cosine of 1/2. So that's using going in reverse. So that's using your cloud. And if it says arc cosine and it's a positive number, you're going to give me a reference angle. So this is going to be pi over 6, pi over 4, and pi over 3. And the way you decide, you look at your original chart, the angle whose cosine is equal to 1/2 is a pi over 3. So that's going to be our answer is pi over 3. And then the next one, you got to do the secant of 5 pi over 3. So when I see the normal angles, I know that secant is the reciprocal of cosine. So look at what I did up here. I did the cosine of pi over 3. Cosine of pi over 3 from our chart is 1/2, but this is in quadrant 4. So from your all Snickers taste chocolate, your cosine is positive quadrant 4. So, but if it was in quadrant 2 or quadrant 3, I would have made that a negative 1/2, right? So that's going to be 1/2. But remember, your secant is the reciprocal of cosine. So if you got 1/2 for that, that means the secant of 5 power 3 is going to be a 2. And then the cosine of 0 is 0 degrees, 0 radians. Remember, go 0, power 2, pi, 3 power 2. So at 0, you got that point. Remember, cosine is your x value. So your x value is equal to 1. So you get 2 minus 1 in the parentheses, which is 1. And now you're supposed to do the arc sine of 1. Now, when you start seeing the 1, 0s, and negative 1s, those are your quadrant angles. This is, remember what this stands for. This is the angle whose sine is equal to 1. And so when you're looking at your unit circle, your quadrant angles, they're those 4 dots. You're looking, where is my y value equal to 1? There's only one spot where that y value is equal to 1. But anytime you see that arc notation, that's going to be the angle. So you got to tell me that's going to be pi over 2 right there. And then we got that one right as well. So those are the first two. And then, so since that's just kind of a weird topic there, we might as well just kind of keep going and do these the rest of them here. So when I do this one, arc sine of negative 1, that's on your unit circle where your y value is equal to a negative 1. Now you got to be careful here. You can't give me 3 pi over 2. When you see that arc notation, this is your domain. You have to give me an answer in between negative pi over 2 and positive pi over 2. The only time you got to worry about this is when you see the arc notation. When we're solving our normal equations in between 0 and 2 pi, we will use the 3 pi over 2. But on these ones and these ones only, you got to use either the negative pi over 2 and positive pi over 2. You're in 1 and 4, and you're in 1 and 2. So just be careful with that. That's why. And then, so that's why when I do arc sine of negative 1, I have to use the negative pi over 2 for that. And then the arc secant of 2, this is the angle whose secant is equal to 2 over 1. Now, if the secant is equal to 2 over 1, that means the cosine is equal to 1/2. And so I want to figure out what angle is it where cosine is equal to 1/2, and where my cosine is 1/2, that's using the pi over 3 for that angle right there. So I got pi over 3. And what you're going to add up, you can use the calculator for this if you need to, but I'm just going to go negative 1/2 plus 1/3. So if I show you, if I go negative 1/2 plus 1/3, it gives me that. But when I switch it to a fraction, I'm going to get negative 1/6. And then the pi just carries down because they both have pi's attached to it. So that's going to be a negative pi over 6. And then the tangent carries down. Now notice, I don't see arc tangent. I'm not thinking about the cloud at all. I just see what the tangent of negative pi over 6 is. So I'm thinking quadrant and reference angle. When I go negative pi over 6, that's negative 30 degrees, which is in quadrant 4. And then when you see the pi over 6, pi over 4, pi over 3, that is your reference angle. So you're going to use your chart. You're going to go tangent of pi over 6. Tangent of pi over 6 is your square root of 3 over 3 number. But then you just got to use your all Snickers taste chocolatey. We said we're in quadrant 4. And so you're doing any normal trig functions, sine, cosine, tangent, or cosecant, secant, cotangent. You got to use your all Snickers taste chocolatey right there. So tangent is cosine is positive quadrant 4, secant is positive quadrant 4. Everything else, including the tangent, is going to be negative in that fourth quadrant there. And then one more of those. When I do arc cosine of radical 3 over 2, that's the angle whose cosine is radical 3 over 2. So that first part is going to be a pi over 6. And then this is arc sine of radical 3 over 2. So that's the angle whose sine is equal to radical 3 over 2. That angle is pi over 3. And again, that's like 1 over 6 pi plus 1/3 pi. And if you need to do that in the calculator, you can just go 1/6 plus 1/3. Might give you a decimal, well, that's just 1/2. So that's going to be 1/2. That's like 1/2 pi, which is the same thing as pi divided by 2. And then I'm going to carry down this cosecant right here. So cosecant of pi over 2, when I see the quadrantal angles, that's the one I just did on letter A. Cosecant of pi over 2 is 1 over the sine of pi over 2. And then the sine of pi over 2 is at that quadrantal, at that point right there, that 0, 1. The sine is the y value. So if it was 1 over, if that was the secant and it was 1 over cosine, then you're going to go 1 over 0. You're going to get undefined for that. But 1 over the sine of power 2, that's 1 over 1, which is equal to 1. So those are going to take a little bit of practice there, but just do the best you can with that. Hopefully that made sense. Just have your chart in front of you, have your cloud in front of you when you're practicing those, and do the best you can with that.